Good morning, I'm Edouard Machery, and I'm the director of the Center for Philosophy of Science and the host of the podcast Conversations at the Center. Today we are hosting Jacob Stegenga. Jacob, would you mind introducing yourself?
Sure. Thanks, Edouard, for having me on your program. I'm a professor in the Department of History and Philosophy of Science at the University of Cambridge. Primarily, I'm a philosopher of science. I've also worked in philosophy of medicine. I've written a couple of books in philosophy of medicine. I've just finished writing a book in general philosophy of science, which touches on some epistemological problems in science. I'm originally from Canada, did most of my training in Canada and the United States.
And today we're going to be talking about the place and the role of values in science. This topic is partly motivated by the conference the Center for Philosophy of Science is organizing this weekend called Revitalizing Science and Values, organized by Arnon Levy, who is a senior visiting fellow at the center. And Jacob is one of our keynote lecturers at this conference, so we are actually extremely pleased and honored to have him as a guest. In addition, he has published recently and he has written several excellent papers on the topic of science and values. So it's a wonderful opportunity to talk about this topic. So to get us started, Jacob, there seems to be an increased interest, for now maybe a couple of decades, on the topic of science and values, the roles that values play in science. So what do you think this increased interest is due to?
Yeah, thanks, Edouard. Thanks for the kind introduction. And you're starting with an important question, an interesting question, but it's a big question to address. So I would answer by sort of speculating. So my speculation would go as follows. Arguably, science itself is having more and more impact on society, on policy, and particularly sciences that might be value permeated. So think of the role of economists as policy advisors, or epidemiologists advising governments during the COVID pandemic, or clinical pharmaceutical research. So arguably, science itself is having big social impact, and there's a worry that some of that scientific work is value permeated. Now, among our colleagues in philosophy of science in the last, say, 25 years or so, there's been, as you say, a big interest in studying the role of values in science. Now, again, I'm speculating here, but probably that's motivated in part by the recognition that there is this big impact of science on society, on policy, by those sciences that are plausibly value permeated. Now, about 25 years ago, one of our colleagues, Heather Douglas, wrote a very important article published in the journal Philosophy of Science, in which she reintroduced the topic for our colleagues. She's kind of reignited an argument that goes back to the middle part of the 20th century. That article had a big impact on our discipline, opened up a bunch of questions for our colleagues, for students to address. And so I'm kind of speculating here, but my thought is that article by Heather Douglas contributed a lot to raising interest in the discipline.
Could you say maybe a few words about these articles and about the arguments that she's relying on or bringing back to our attention?
Sure, of course, yeah. So the argument in that article, this was published in 2000, the argument is often called the argument from inductive risk. I take this argument to be the most important argument in the literature on values in science. So the basic idea is that in some contexts, particularly policy-facing contexts, scientists sometimes have to take a binary attitude towards a hypothesis, like accept or reject, believe or disbelieve, assert or don't assert. Now that's controversial, and I can say more about that a little bit later, but at least in some cases, it looks plausible to think that sometimes scientists have to take a doxastic binary attitude towards a hypothesis. And in those policy-facing contexts, if scientists can predict the consequences of error, then their evaluation of those errors is liable to influence the scientific reasoning itself. So for example, if we approve a drug for clinical use when it ought not be approved because, say, it's harmful or it's not very helpful for patients, then we're liable to expose patients to this harmful drug. On the other hand, if we reject that drug for clinical use when it's in fact beneficial, then we're denying patients access to that drug and harming the financial interests of the company that makes the drug. So the worry in that structure, in that argument, is that the extent to which or how we evaluate those consequences of error can influence the kind of internal workings of scientific reasoning itself. That's the argument in a nutshell. There's lots of controversial and important points in that argument that I think are worth attending to.
Yeah, good. So, in fact, I'd like to hear a bit more about that. I mean, you mentioned 2 points. One of them was the idea that the scientist, as a scientist, must make a binary decision, accept a hypothesis, reject a hypothesis, and you mentioned it was a point that was controversial, rightly so, I believe. You also mentioned very carefully in your description of the argument that the argument seems to assume that the scientist is able to anticipate or form at least justified beliefs about the consequences of our action, something which might be true maybe in some areas of science, seems unlikely to be true or not as obviously true in other areas of science. And there might be other also issues about the argument, so maybe you can have something to say about some of these points or some of these issues.
Good, yeah, thanks, Edouard. So as you say, there's a lot of issues here, and addressing them requires some delicacy. So for example, one important distinction that we can draw is whether or not we're thinking about the domain descriptively or normatively. So let's start just by descriptive thinking about the domain, thinking about these questions. It's plausibly descriptively true that scientists sometimes do, and perhaps often do, take binary doxastic attitudes, or at least assert binary doxastic attitudes in the public domain. So we saw this, for example, during the COVID-19 pandemic. Epidemiologists would assert a hypothesis in a non-graded way that was meant to be policy-facing. So descriptively, it looks like that does happen sometimes. There's the normative question, ought they do that? One common response to the argument from inductive risk that goes back to some Bayesian philosophers in the middle part of the 20th century and has been reignited by philosophers in the early part of the 21st century is exactly along the lines that you gestured towards, namely, scientists can and should report hypotheses along with the uncertainties that they have towards those hypotheses, and should routinely be hedging the kinds of claims that they make to the degree that the evidence warrants. So rather than say, yes, this hypothesis is true, or I accept this hypothesis, say something like, well, the evidence supports the hypothesis to such and such degree, or plausibly or probably this hypothesis is true, but maybe not, so asserting some kind of hedged, qualified claim. Now, the response to that in the philosophy of science literature, now going back 10 years or so, is to say, at least in some policy-facing contexts, that kind of hedging, that kind of uncertainty conveyance can be less action guiding for policymakers. This is how the argument goes. Sometimes policymakers need unhedged, unqualified claims to guide the kinds of policies that they're supposed to make. So some of our colleagues call this a no-buck passing principle. If scientists convey uncertainties in highly complicated ways with hedged hypotheses, they're effectively passing the buck to the decision makers to figure out what exactly to think about the hypothesis in question. But those policymakers aren't trained to do that. So our colleagues think that some scientists in some domains should be guided by this no-buck passing principle. Now, there's a lot to be said about this.
Yeah, that's an interesting principle. I mean, one might think it cuts both ways. I mean, it's definitively true, I believe, that many policymakers, not all, because of course some policymakers have a background in science, but many policymakers are not trained to understand uncertainty, which is of course not easy to do for actually most of us. But it's also unclear whether on the other side, the scientists themselves are able to integrate the values to their decision-making process, right? So they might be trained, maybe, to deal with uncertainty, but they might not be trained to see how values should be integrated with the certainty. So that argument does not quite look at the point of decisions clearly on the side of the scientist, right? It's not as easy as it seems to be suggesting.
This is an important point that I think has not been addressed well enough in the literature. I think there's two things to say here. So if scientists are using their findings and reporting the findings in unhedged ways to guide policy, as you say, they might not be trained to properly integrate the values that are required to formulate policy with the scientific work. But moreover, it's not their role responsibility to do so, right? So policymakers, at least in liberal democratic societies, are elected, they're beholden to citizenry. The populace has conferred agency on the policymakers to make policies that are in the best interest of citizenry. We're speaking ideal here. The citizens don't vote for scientists. So policymakers are the ones who ought to be formulating policy. And so I think there's both the point that you raised about scientists not being trained to incorporate values with scientific work, but also this issue of role responsibility.
I agree. So we've been talking a bit about the argument that people who think that values do and arguably should matter in scientific research, what their views are, what one of the main argument is. Now I'd like to know what your views are that you've been developing in a recent series of papers.
Thanks. Okay. So, yeah, I should say that, so I highlighted at the beginning, my view is that the argument from inductive risk is probably the best argument in the literature that challenges the so-called value-free ideal, the ideal that says scientific reasoning should be free of social values, political values, ethical values. So I take this argument to be the best argument on offer that criticizes the value-free ideal, and any serious contribution to the literature now that wants to defend a value-free ideal has got to reckon with that argument, has got to find a way to either find a flaw in the argument or find a way to articulate a value-free ideal which sidesteps that argument. So with a friend of mine, Tarun Menon, we've been working for a few years writing a couple of papers that tries to do just that. So we tried to articulate a version of the value-free ideal which sidesteps the thrust of the argument from inductive risk. So my view is that science should strive to be, as much as possible, value-free. That's the slogan.
Very good. It's worth mentioning that that defending the value-free ideal in philosophy of science these days is very much a minority view. The consensus, I believe, among our colleagues is that values do matter, should matter, must matter. So you're really on the minority side in philosophy of science, at least with respect to that topic.
Well, yeah, as you know, philosophers love being in the minority side, so I take this as a big compliment. Thank you, Edouard. But I think what you're saying is true. Thanks to that really important article by Heather Douglas that I've already mentioned, and thanks to a lot of quite interesting and important work that followed that article by many of our colleagues, there's been this emerging consensus that values can, must, should influence the inner core of scientific reasoning. I can't count how many times I've been in a conference in which one of our young colleagues, maybe a PhD student, will raise their hand to ask a question, and the preamble to the question will be, well, everybody knows that the value-free ideal is dead, but now let me ask you blah, blah, blah. And I think that's gone too far. So the consensus, the dogma is that the value-free ideal is dead, and my hope is that with work by Tarun and I, that we've tried to resuscitate a version of the value-free ideal that's very much alive.
Very good. So what is your main argument or your main arguments for a defense of the value-free ideal?
Okay, so the main argument in these two articles is to first step back and ask, what really is meant when one says values influence scientific reasoning? What does that word mean, influence? So we give a somewhat technical definition of influence there. We characterize influence as difference-making. So I guess that notion, difference-making, is very popular here in Pittsburgh, thanks to some of your esteemed colleagues. So values make a difference to inference when, if you've got some fixed evidence, if you if you jiggle with the values, you get different conclusions, and those conclusions are inconsistent with each other. So that's the sense in which values are difference makers to inference. Now, on its face, there's a very plausible principle that values just should not be difference makers to inference, for a very kind of old school, traditional, old-fashioned kind of reason, namely, our values don't tell us the way the world is, right? Our values tell us the way the world, how we want the world to be, but our values don't tell us the way the world is. So a very plausible just starting point, any thinking about values in science, is a kind of difference to inference principle. The only difference makers to inference should be truly epistemic, should be truly evidential. Okay, but how do we deal with the argument from inductive risk? We start by distinguishing what we call end state desirability from like a procedural form of desirability, from a process desirability. So one way to read the argument from inductive risk is to say that one plausible conclusion from the argument from inductive risk is that science should not be value-free in its end state. And why is that? Because sometimes we want the results of science to guide action, to guide policy. I mean, here's a simple thought experiment. We can imagine a science, call it austerology. So in austerology, our scientists, they go about studying the world, but they never make any claims about the way the world is. They never make any assertions whatsoever. So in austerology, the argument from inductive risk doesn't get off the ground, right? Because there's no accepting or rejecting hypotheses. There's no saying this is the way the world is. Okay, so in austerology, we've got something that looks broadly like a science, but the argument from inductive risk doesn't get off the ground, and therefore we got a value-free ideal. However, goes the critic of the value-free ideal, there's something deeply problematic with austerology. Austerology can't really tell us much about the world. Austerology can't guide us in our policies and our technological development. We need scientists to at least sometimes stick their necks out and say, the world is like this. This hypothesis is worth acting on for policy deliberation, for technological development. Okay, so if we at least grant that desideratum from the critics of the value-free ideal, then it follows that a pure value-free science isn't end state desirable. Okay, but it might be desirable to pursue. It might be pursuit desirable. So what that means is it could be, and we argue that it is, desirable that scientists pursue value freedom. They pursue a complete state of value freedom. They eliminate all of those situations in which values are difference makers to inference. And they do that as much as they possibly can, even if it's the case that the end state of complete value freedom would be undesirable. So that's the argument in a nutshell. Now that raises all sorts of possible challenges, all sorts of concerns that our referees had, and so on. And so I could go on and on and on about how we defend the kind of nuts and bolts of that position.
Very good. So it's really an exciting argument. I have a question about the first part of the argument, about the idea of values being difference makers. And now it has a sense in which that is obviously true, but I think it's going to depend to some extent on the range of values that you are allowing yourself to consider. So now if you think that you can consider any possible value, just like you would do any possible counterfactuals is acceptable to be considered, then it is right that values are bound to make a difference. But one might think that this is not exactly the right range of values to be considered. One might put some bounds with respect to the right values. So, for example, one way to do that is look at existing values, not at possible values, actual values. And in some cases, one might think that the range of values is actually very limited, and variation within that range would not make any difference with respect to the inference one might want to draw. Or one might have slightly different ways of bounding the scope of values to be considered, maybe on moral grounds, only the morally right values, or maybe the values which are acceptable from a political point of view, maybe are the ones that should be considered, and maybe those values don't make a difference or make less difference, or maybe it's just only at some specific point in the process. So is that something you've thought about, is the range of values?
Yeah, thanks for that question. There's sort of two parts there. On the first part, I endorse 100%, and the second part, I want to kind of sidestep. So on the constraining the range of values that could be considered, right? So if we allowed like an infinite range of possible values, then we're going to have these very bizarre value sets that could cause disagreements between scientists or between hypothetical scientists, right? So we would always be faced with difference makers to inference. And if that's true, then no matter how much good scientific work you do to try to eliminate difference makers to inference, you're always going to be left with these difference makers. So Tarun and I deal with this exactly in the way that you suggested. We constrain the kinds of value influences that we're concerned with to actually existing values. So that's step one. And then step two, you're putting your finger on a move that's been very popular in the literature in response to the argument for inductive risk. So the move is basically like, right, values are influencing science this way or that way. So now the question is, which values should be doing the influencing? So we might say it should be democratic values. So we should have somehow bring in citizen representatives into the scientific process, into the policy advising process. Somehow try to make a case, maybe a moral or a political case, that there's a constrained range of values that should be influencing scientific reasoning. Some of our colleagues call this the new demarcation problem. It's a nice argument by nice article by Will Holman with that title. Now, if Tarun and I are right, there's no new demarcation problem. That's because our view is that all value influence should be eliminated. So if that's the case, then there's no set of values that are okay to be influencing scientific reasoning. All value influence should be eliminated. So that's the sense in which I want to sidestep the sort of second part of your question.
Except if all these values yield have the same impact on inference, because in which case they don't make any difference. Right?
Good. Yeah, right. That's exactly right. Yeah. So we've been speaking highly in the abstract, right? We haven't given any concrete examples. And so one of the really nice things about that famous Douglas article is it's grounded in quite a compelling example. So the idea is the example goes like this. Public health epidemiologists were studying whether or not some chemical, dioxin, causes harmful health outcomes. They had the same set of evidence, these tissue samples from rodents that had been dosed with dioxin at different concentrations. And there were different groups of public health scientists who studied these slides, and those different groups came to different conclusions. The group that worked for the company that manufactures the chemical found that the chemical was actually safe at pretty high doses. The group that worked for Public Health Agency found that the chemical was unsafe, even at lower doses. So same evidence, different conclusions. So that's the kind of situation that motivates the literature. And so, yeah, that.
Good. I'll mention another point, I suppose, which is probably philosophically controversial, and I'm sure you're fully aware of that, is the idea that you can easily distinguish the epistemic from the non-epistemic. As you know as well as I do, there's a large trend in epistemology, so in the discipline outside philosophy of science, that argues that, in fact, knowledge itself is deeply contingent on non-epistemic factors. So it's that you can't actually distinguish the epistemic from the non-epistemic. So you're rejecting these ideas. Sometimes goes around the name of pragmatic encroachment in epistemology. So you seem to be rejecting this set of ideas.
Yeah, I'm really glad you're raising this topic. It's an important one. So I'll come back to pragmatic encroachment in just a second. One thing that I think hasn't happened enough is epistemologists and philosophers of science who are interested in values in science working together to draw on each other's work. And arguably, some of the literature on values in science could be improved by attending to some basic distinctions in mainstream epistemology. Now, generally, I don't think that's the way to go. So generally, I don't think philosophers of science should be taking their lessons from mainstream epistemologists. In general, I think the direction of fit should be going the other way. So that's a kind of programmatic commitment on my part. But in this case, I think there's a lot to be learned. So take this really basic distinction in individualist epistemology between internalism and externalism about justification. It looks like the critics of the value-free ideal can't be entertaining an externalist form of justification, because externalism about justification involves basically an appeal to objective standards of justification. But if values are influencing what we take to be true or false, that's not objective. Okay, but the problem is that, so what are they left with? Well, maybe they're left with internalism about justification, but my hunch is that most philosophers of science are uncomfortable with internalism about justification, precisely because one thing that makes science special is its sort of intersubjective, objective-facing methodologies. And so, when you kind of do a random poll at the pub with philosophers of science, most of them have externalist intuitions. Well, actually, I'd be interested to hear what you think about this in your XFI work. So that's just one instance in which drawing on this very basic distinction in individualist epistemology could help sort out some lack of clarity in the values and science literature. But then there's this issue about pragmatic encroachment. There's one article that I'm aware of, at least, by another friend of mine, Boaz Miller, who argues that the values in science literature, especially the argument from inductive risk, is structurally similar to the pragmatic encroachment argument. And so part of what you were asking me was, if I'm averse to the conclusion from the argument of inductive risk, am I also averse to pragmatic encroachment? And I guess I'd have to say yes.
Very good. We're reaching the end of our discussion, but before ending the discussion, I'd like to ask you whether the work you've been doing on values and science intersects in interesting ways with your broader work in philosophy of science. Now, you're quite well known for some work in the philosophy of medicine. You have developed this view, medical nihilism, which has been very influential and widely discussed in philosophy of medicine. So is there some connection, or is that a side project in your philosophical work?
Oh, thanks for that question. So in that book, Medical Nihilism, I was worried about the influence of industry on setting the research agenda and on sort of fine-tuning research methods, basically in a way that allowed industry to get the evidence that they wanted for supporting their various products. And so it looked like a pretty clear instance of value influence on science. And rather than stop there, I think the project is then to figure out sort of what to do about that value influence. So yeah, I was worried about value influence in that earlier work. I have very recent work that I've become interested in which the project is to take the structure of the arguments in the values and science literature and see if they can apply to other topics in philosophy. So for example, now this is a bit from left field, but I'd be curious to hear your thoughts about it. There's this literature, just war theory, which asks about the morality and ethics of war. Now, a really important notion in just war theory is the notion of proportionality, which says if you're planning to do some violent action, the harms that will result from that action have to be proportionate to the expected goods of that action. So then we can conceive of proportionality as a problem of estimation. It's essentially a problem of assessing a hypothesis. The hypothesis is this violent act will be proportionate. And now we can see that the argument from inductive risk might get off the ground, right? So if you're an officer planning some violent action in war, the extent to which you disvalue the various outcomes, say harming citizens of the enemy versus the various expected goods that you might have, like achieving a particular local military aim. Well, the worry then is that the argument from inductive risk will apply to precisely how you estimate proportionality. It seems to me that the machinery of the argument for inductive risk applies there in a completely non-controversial way, in a much more deeper way than it applies to assessing scientific hypotheses.
Yeah, that's a really interesting thought. I'm really curious now to read this paper, hopefully in the coming weeks or months, maybe.
Thanks, Edouard.
All right, I think it's time for us to stop this discussion. Thanks again, Jacob, for joining us today.
Thanks for all the great questions.